Hello and welcome to part 2 of lesson number 6 in Unit 6, Solving Problems with Quadratics in our grade 10 academic math class. This lesson is about finding strategies for solving problems if it's not obvious by the title of the lesson what type of word problems you're going to be solving. We've walked through sort of a two-step process, or I guess, kind of a two-step process where you can arrive at 3 different outcomes. The first is to look for a clue word in the word problem like maximum or minimum or greatest or least, biggest, smallest, etc. If you find that word, you're going to have an optimization problem and you're going to be completing the square to find a vertex. If you don't see that clue word, then you're going to create the equations for the word problem, and you're going to look at the highest degree in either of the word problems. If you have a degree 2, you're going to be solving a quadratic word problem, which we do by substituting the linear equation, or a reorganized linear version of the linear equation, into the quadratic equation, solving by factoring or using the quadratic formula. You can use the discriminant there to help you if you want. If the highest degree in any of the equations is 1, so we have first degree functions, then you have a linear word problem, and you're going to solve that using substitution or elimination. Our first word problem was an optimization. That went pretty well. Let's jump into number 2. So it says, $1 million was invested in stocks and bonds. The stocks earned 12% interest and the bonds earned 8% interest. At the end of the year, the total interest earned was $100,000. How much was invested in stocks and how much was invested in bonds? Okay, so I started with a couple of let statements, and if you're not sure which let statements to, or how to generate your let statements, I typically recommend looking at the last sentence of the word problem. It will tell you what it is that you're after, and often that is going to be the variables you're going to want to define. So it says how much was invested in stocks and how much was invested in bonds. So I let X represent the amount invested in stocks. I guess I should put some units on there. That's not great. So amount invested in stocks, and I guess that'll be in dollars, and the same thing in bonds in dollars. There we go. Okay, so I have some let statements. I don't see my clue word in here anywhere. I don't see max, min, biggest, smallest, any of that stuff. So I'm going to be looking for the degree in the equations I'm about to build. So I'm looking for relationships between two variables. The first sentence contains one. It says that there was $1 million invested in stocks and bonds. So if we take, we'll call this equation number 1, if we take the amount invested in stocks and the amount invested in bonds and add them together, that's going to give us our $1 million. So that came from this sentence right here. What is the second equation going to be? So it says the stocks earned 12% and the bonds earned 8%, and that the total interest earned was $100,000. So there's kind of like two pieces of information there. The first, of course, being that the stocks earned 12%, the bonds earned 8%, and total earned was $100,000. So I'm going to build that into equation number 2. It's telling me that percentage-wise, 12% interest on the stocks. So X was my stock. So if I want to write 12% as a decimal, it's going to be 0.12x. And if I want to write 8% as a decimal, it's 0.08. I think it was 8%. Yep. And I know that interest earned on stocks, the X amount, and interest earned on the bonds, the Y amount, together total $100,000. So I have two equations. That was the orange one right there, so that's the orange information. So I now have two equations. Let's look at those and check for the degree. So what's the largest degree in either of these? So degree is sort of a condition of the largest exponents. So here has x to the exponent 1, y to the exponent 1, and so that's a degree 1 function, or a first degree function. Here we have another two first degree terms, I guess. So overall we have first degree functions. So we're going to solve this. This is not quadratic. We're going to solve this like it's a linear equation, or a linear system, I guess. And we're going to solve this by either substitution or elimination. Doesn't really matter which one. It looks like it's kind of sort of set up for either one, really. So the first thing I'm going to do, though, is I'm going to clear these decimals because I'm not a huge fan of the old decimals. So I'd rather be working with whole numbers when I can. So to clear the decimals, I'm going to multiply this by 100, every piece of it. So 1, 2, 3 things are going to be multiplied by 100, and that's going to be my new equation number 3. So that's going to give me 12x plus 8y. I'm going to add 2 more zeros to this guy. There's 2 more zeros. So if I divide this up, that's going to give me sort of into groupings of 1,000. That's going to give me 10 million right there. So here's what I have. I have 12x plus 8y equals 10 million. So we are going to now solve using one of the two methods, either substitution or elimination. Let's maybe do substitution. So we're going to do, I'm going to write out sort of our instructions here. We are going to solve using substitution. Substitution. So the first thing I need to do then, I am going to reorganize our first equation to isolate one of my two variables. So the variable that I'm going to isolate will be x, I guess. So that's going to be x equals 1,000,000, 2, 3, 1, 2, 3, minus y. There we go. And now if, hopefully you remember this, but I'm going to substitute a known value for x, which is 1,000,000 minus y, into this equation down here. So I'm just going to do a little bit of numbering here just to keep everything straight. So this is reorganized 1, we're going to call 3, and multiplied 2, we're going to call 4. So using substitution, we are going to sub 3 into 4. Okay, so 3 into 4, let's get it going. So we've got 12, and instead of an x, we're putting in 1,000,000 minus y plus 8y equals 10 million. 2, 3, 1, 2, 3. Okay. So now we're going to expand out and we are going to isolate y. Again, the purpose here of substitution is to get rid of two variables and sort of have one variable instead. So as you can see, we only have y's kicking around now, so we're going to expand out, gather like terms, and then off we go. So we have 12 times 1,000,000, so that will be 12 million, and minus 12y plus 8y is going to equal 10 million. Okay, so I'm going to transpose. I'm going to take 12 million and move it to the other side of the equation by subtracting 12 million. And on the left side, I'm going to gather together my like terms. So on the left side of my equation, I have negative 4y. And on the right side, I have negative 2 million. Now I'm going to isolate y by dividing both sides by negative 4. And y then will equal, so let's pop this into the old calculator here. So there's my negative 2 million, divided it by negative 4, and that's going to give me 500,000. Okay, so I have found one of my two values. I have found y, which is the amount invested in bonds. So now I'm going to sort of do some horizontal work over here, and I am going to sub y equals 500,000 back into number 1 in order for us, actually I guess 3 is probably a little bit easier, isn't it? Into number 3 to find x. So x will equal 1 million minus 500,000, and x will then equal 500,000. Okay, so here we have our two solutions. We know what x is equal to, we know what y is equal to. Now we just need to pop a therefore statement on this thing. So therefore, the amount invested in both stocks and bonds writing takes so long. Stocks and bonds is $500,000. All right, there we go. So there is our second word problem worked through. So again, hopefully the modeling of the following of the infographic from the first page helps you determine what type of solving you're going to need to do or what mathematical operations you're going to be after. The worksheet is questions 1 to 8, and there is a variety of them in here, and that's kind of the point. The point is to get you thinking and running through that sort of algorithm. Is it optimization? Does it have max, min, biggest, smallest? If it doesn't, create the equations and what's the degree, and is it a quadratic you're going to be solving, or is it linear that you're going to be solving? So this is a hodgepodge of all of them. I totally anticipate people having lots of questions. So if you have lots of questions, please just email me. I'm happy to make videos showing you how to work through some or all of these word problems, but obviously try them on your own, and if you get stuck, for sure email me, let me know, and I'll be sure to post some completed solutions for how to get the answers to all these word problems. So that's it. Good luck with the homework from this very challenging lesson.